Welcome to Tech Tuesday from the Precision Golf Workshop. Today I wanted to explain what SST Pure is. SST Pure is a patented shaft alignment technology used by countless PGA Tour, European Tour, DP World Tour and Live Tour players. In layman terms, no shaft is perfectly round and straight, whether it be steel or graphite. There are variances of offline bending and twisting no matter what your level of game is, and we look to eliminate this shaft instability by finding the shaft's correct orientation and aligning that with the target line. Now, many people have said, well, surely puring is for the better player because they can feel the difference, but that's why high handicap golfers, I will get through this in one take, I promise, also see the benefits in this technology because they can't feel if a shaft is creating a slight shot shape. They just want to swing. So if they can't feel it, they can't compensate for it. We've had many high-end, decent players who felt that one particular shaft in their set has not felt quite right. Despite measuring perfectly statically on paper, there would appear to be nothing untoward. By disassembling that club, puring the shaft and rebuilding it, the players commented that it feels completely different. So onto the machine. The first part of the test is we load the shaft into the chuck, which holds the shaft like a golfer's grip, so greater pressure to the rear and the front of the chuck. We're trying to simulate the golf grip as much as possible. Okay, so we now move the shaft into the logo up position. This is to create a control test, something to compare the pured results to. Quite a few manufacturers will actually have 360-degree graphics now because they're aware that aligning does go on and they want their product logo or model name to be visible no matter which way the shaft is installed. Moving on swiftly, the next page is just customer and shaft information purely for the report. It bears no bearing on the result of the puring, it's just for the report, as I said. Driver. Okay. So the first part of the test is called the LSI, the Load Symmetry Index. The tip of the shaft is deflected underneath this load cell, and it's slowly rolled through its circumference. The change in force exerted upwards is recorded on a graph, which you'll see here. Now, if this shaft was perfectly round and straight and uniform in all its bending properties, the shaft would exert a constant load against that load cell, and that would result in a straight line, which it never exists. There are varying amounts of ebbs and flows in this graph, but what you can see here is a trough and a crest, which indicates that this point here is the point at which the shaft was pushing up the most against the load cell. So we will agitate this shaft to see how it would perform in its logo up position, how the manufacturer would install it, and then we'll start testing around this point here where the shaft was pushing up the most to see if we can minimize this offline bending and twisting. We first install a tip mass which simulates a club head. This one's for woods, this one's for irons and hybrids. The shaft will move to its logo up position. The arm comes across, lets go, and then the pattern of motion is recorded with lasers. And here you can see these are concentric circles. So by moving to that hard point on that graph, you can start to see this vertical deviation is squeezing. And it'll carry on testing in smaller and smaller and smaller increments until the movement doesn't improve any further. You may have heard of sayings such as flow, flatline oscillations. This is essentially trying to do a similar thing, but this is the only computerized version of shaft alignment. And it's not to be confused with flowing, which just uses lasers against a board, or spining. They are completely different processes. Shafts can take between 1 minute and 4 minutes to pure. If a shaft takes 4 minutes to pure, it doesn't mean to say that it's any worse. There's continual refinement in the performance. So eventually when this shaft can't improve anymore, the printer will come down, it'll mark a line, and we use that line to install the shaft at 12 o'clock in the hosel. That means that the shaft's most stable plane is 9 o'clock, which is target facing. Okay, so we can see that the printer is coming down to mark the shaft, and I will show that to you. The shaft did mark correctly. The two further parts of this test, which aren't, they have no bearing on the performance of the shaft. It's a straightness test, a bit like if you roll a snooker cue, you can see that the tip does that. Again, it's just showing you if you look down the shaft from the butt to the tip, it wouldn't be wouldn't be totally straight. It's just a confirmation that shafts aren't round and straight. This last test here is a torque test. There's no industry standard for torque rating. Some manufacturers use a particular test, others use another. This is a standardized torque test that you can use to compare your cut and prepared shaft against the manufacturer's suggested specifications. So here we can see we have the logo up test before and the pured result. The final analysis is that the shaft was rotated 121.58 degrees from the logo up position, resulting in an improvement in out-of-plane oscillations by 92.84%, which is quite some improvement. So I will just take the tip mass off. Just to show you the alignment mark, which hopefully you can see. And that is installed at 12 o'clock, meaning that if you're a right-handed golfer, the target line is that way. So I hope this has explained the puring process sufficiently. We pure all equipment, not because we have to, because we want to make sure that every club that we build performs as perfectly as possible for you. And we hope that this is great evidence to support the fact that not only should golfers be playing with correctly fit and built equipment, if you're not playing with pured equipment, you just can't be sure what the shaft is doing, no matter the quality of the shaft. Shafts range in price substantially, and every shaft will benefit from the SST Pure process. Thank you for watching.